we are going to talk about the parent functions. So in Algebra 2, you learn about all the functions, and we learn to graph them and write down domain and range, and then later we transform them. The parent functions are like the very basic function, like y equals x is a parent function. Y equals x squared is a parent function. So over here on my screen, I have the parent functions. So what I want you to do is look at your notes, and I want you to read each function name and match it with the equation. So we all know the linear one, right? What is that? Look up there. Which one's the linear? Y equals x. Okay, there we go. Okay, now look at the rest of them, and you're going to write them down on your notes page. So the next one is quadratic. So look up there. Which one is our quadratic? Do you remember? You learned it in Algebra 1.
Well,
Take a risk.
It's been a year since then.
Or 2. Or 3. What? X squared. Thank you. Good job.
Next one.
All right. What do you think cubic is? Yes. Square root. What's the square root? Yeah. What is cube root? Yeah, so that's called the cube root. Y equals cube root x. Whatever's in this little crack is what the value is. So usually it's 2 if there's nothing in there. It's 3 in this case because it's cube. All right, next page. Exponential. Look at those and see which one do you think is exponential. Y equals 2 raised to the x, because where is x? The exponent. Exponential, x is the exponent. Okay, logarithmic. Yeah, y equals log base 2 of x. And if there is no log, like the base, there's nothing there, it'd be log base 10. That's why the basic one, I guess. All right, and then our last one. Whoops, I just messed up. Oh, we have 2 left? Oh, okay. Yes. Yeah, 1 over x. Rational numbers they can be written as a fraction. So that's where we get rational function. All right, absolute value. Yeah, y equals absolute value of x. So you have part 1 done of parent functions. You know the equations. So that's good. You could kind of use context clues to figure it out, especially if you're given some multiple choice up there. All right, so let's go in. And we are going to graph this and find domain and range. All right, so if y equals x, let's make a table. Y and x are the same. So this is -2. Y and x are the exact same. That makes this easy. And now we will graph it. -2, -2. Use your ID badge to make yourself a straight line, because linear is a line. There we go. And extends forever in both directions. All right, so domain is our x values. Range is our y. So for domain, it's left and right. So we look left, we look right, left, right. And we have arrows going left and right. So that is the negative infinity to positive infinity. Or we could say all real numbers. And then range is bottom to top, how far down and how far up. Bottom to top. Yeah, it's negative infinity, positive infinity, because we have an arrow going down to forever and an arrow going up to forever. Or all real numbers. All right, let's go to quadratic. Y equals x squared. So for x squared, we would plug in values. So we would do negative 2 squared. Negative 2 in parentheses, right? Like this. Negative 2 squared is positive 4, right? Yeah. Negative 1 squared. Negative 1 times negative 1. It's just 1. 0 squared. One squared. And 2 squared. All right, so we need to plot these points. So negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. Do you remember what the shape of a quadratic is? Do you remember what it looks like?
Yeah, it's just like
a big U. It's called a parabola.
Yes.
So you're going to make it curved. There we go. Okay, so domain, left and right. Going left, we have an arrow. Going right, we have an arrow. Negative infinity to positive infinity, or all real numbers. Okay, range is bottom to top.
0.
Yeah, it starts at 0 to positive infinity because it doesn't go below the x-axis. So we have a parentheses. No, we have a bracket on 0 because it's included. And then a parentheses on infinity because you can't include infinity because it goes on and on forever. Okay, so far, so good? You remember these two? All right. So let's go to cubic. We have something to the third power. So negative 2 to the third power. Remember, we did that for our warm-up. Negative 2 raised to the third. What did we get? Negative 8. Third power means negative 2 times negative 2 times another negative 2. Okay, negative 1 to the third power. Negative 1. 0 to the third power. 0. 1 to the third. And 2 to the third. That's 8. Okay, so let's put this in. Negative 2, negative 8. Things all the way down there. 2, 4, 6, 8, yeah. Negative 1, negative 1. 0, 0. 1, 1. 2, 8. Okay, it's not a line, so don't make a line. It's going to be curved. So this is going to go like that. So do your downhill. Let me try that again. It's kind of like a parabola, but it's going to be flipped on both sides. So the downhill looks like that. The uphill looks like the right side of a parabola, kind of. Looks like that. In the middle, they're close together. And then as you go further out, it goes out straight. So it goes left and right. Negative infinity to positive infinity. Or all real numbers. Okay, bottom to top. These also have arrows, right? So it's negative infinity, positive infinity. All real numbers. Okay, let's go to the next one. We have square root function. So the square root of x. Square root of 0. 0. Square root of 1. Square root of 4. Square root of 9. And square root of 16. Okay, plot it. One, 2, 3, 4. Yeah, we could do 9 though. Like I can go over to 9 and up to 3 like that. Kinda. I don't like that. Let's do this. Nope. There we go. Kind of weird. Weird looking one. Okay, so this is, let's go left and right. It doesn't have an arrow going to the left. Where does it start? 0. But then it has an arrow going to the right. Positive infinity. Bracket on 0. Okay, range bottom to top.
0.
Yeah, 0 to infinity. It's going to go on and on. Okay, these two, x squared and square root of x, are inverses of each other. If you take the square root of something, that's the opposite of squaring something. And so if I put this one on that, they would show up as inverses. They're opposites. All right, let's go to cube root of x. Different color. All right, so cube root of -8. And we can put that in the calculator. Do y'all know how to put that in the calculator? Let me pull it up and see if I can find my calculate. I think it's under math. If you go to math, you go to number 4. See if it's the same on your calculator.
Yes.
Okay, cool. And then put in -8. Yeah, -2. See it? You go to math, that's number 4. So it's -2. Cube root of -1. Put that in the calculator. Cube root of 0. Cube root of 1. And cube root of 8. No, not a parabola. -8, -2 right there. -1, -1 right there. It's a weird looking graph. 1, 1, 8, 2. So it is actually, if you look at,
It's the same thing.
yeah, it's the same way, just turned sideways. So see how that one looks? If I were to rotate my paper, it would look just like this. All right, so do that part of it first. Just kind of like the square root one too. And then do the other part. Like that, there we go. All right, so domain left and right. All real numbers. Working around -infinity, positive infinity. All real numbers. And then range bottom to top. That arrow is going to keep on going down. And the arrow on the other side is going to keep on going up.
Negative.
Yeah, -infinity, positive infinity, which is all real numbers. All right. 2 raised to the x. So we would do negative, oh no, it's positive 2, isn't it? It'd be 2 raised to the -2. Yeah, 2 raised to the -2. 0.25. Two raised to the -1. So 0.5. Okay. 2 raised to the 0. No. It's 1. Yeah. Anything raised to the 0 is 1. 2 raised to the first. Just 2. 2 raised to the second. 4. All right. So -2 to 0.25. Do you see where I put it? So halfway would be here, and you'd go halfway between halfway. So it's right there. Okay, and then the next one, negative 1.5, so that is the halfway. 0 is at 1. 1 is at 2. 2 is at 4. Just for fun, let's do the third one. 2 to the third power. Put that in your calculator. What is 2 raised to the third power? 8. So 3 is at 8 right here. Okay, this one is not going to ever be negative. So it's going to just go along the bottom here. And then it's going to shoot up. Exponential. This is what I want to happen to my husband's crypto wallet. Hadn't gotten there yet. Maybe one day. But we want exponential growth there. It just shoots up. Okay, domain, left and right. Arrow going left, arrow going right. Infinity. Or all real numbers. Okay, bottom to top. Yeah, 0 to infinity. Okay, let's go to log. Log base 2 of x. All right, let's see how we put this in the calculator. Math. Oh, math A. Go down to log base. We could put a 2 in there, and then we're going to put in 0 first. Log base 2 of 0. So I went to math, and I went down to where it said log base. Oh, overflow error. That means it's undefined. It can't exist. So just put UND. That means there's an asymptote at that point. We're going to learn about that. Okay, and then we can do log base 2. Oh, whoop, 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 whoop. Log base 2 of 1. Log base 2 of 1, 0. Log base 2 of 2. I'm going to just go up here, bring this down. Put it in. 1. Log base 2 of 4. Is it 2? And log base 2 of 8. Should be 3. All right, so undefined for 0. So that means that there's a asymptote right here. You can draw a dotted line. That means it's never going to cross it. 1, 0, 2, 1. Let's see. 1, 2, 3, 4, 2, and 8, 3. So this goes like that, and it's the inverse of the previous one. So it's going to just go right along that asymptote, but never actually cross the 0. All right, left and right. 0 to infinity, but it doesn't actually touch 0. So this one's going to be different. It's going to be a parentheses. I think the other one should have been in parentheses too. So we need to go back and fix that one. You already did. So y'all fix the last one. This should have been parentheses. There we go. The reason is because it's not able to actually cross it. This is an asymptote too. So it doesn't actually cross it. All right. And then our bottom to top. How far down does it go? And how far up does it go? So it's all real numbers. Okay, y'all stay with me. We're almost done. We got 2 more. Stick with me. Remember the prize at the end. Okay, let's go to rational. 1 over x. So this would be 1 over negative 2. Let's write it as a fraction. I mean, as a decimal. What's 1 over 2? 0.5. So negative 0.5. Okay, 1 over negative 1. Just negative 1. 1 over negative 1 over 2. Don't know it? Put it in the calculator. What is it? Alpha y equals 1 over, and then another fraction, negative 1 over 2. You don't have to do all that?
You would just do 1 divided by 0.5.
Oh, yeah, that would work. All right, so what was it? Negative 2? Okay, 1 over 0. Can it happen? It should say, like, can't do that, error. So undefined. That's going to be our asymptote. All right, 1 over 2. It's just 2. 1 over 1. And then 1 over 2. 0.5. All right, so negative 2, negative half. See where I plotted mine? Negative 1, negative 1. Negative half, negative 2. Then we have an asymptote. Draw yourself that. Little dotted. And then half 2. 1, 1. 2, half. This one's funky. It's going to go like this. So this is what, the rational function? It's like that. And then the other one does the opposite way. This one actually has 2 asymptotes. Or just, yeah, both axes are asymptotes. So the domain is everything but 0, and the range is everything but 0. So the way we're going to write that is negative infinity to 0. Union together with 0 to infinity. That means everything but 0. And then range is the same thing. Everything but 0. So the way you write that is like this. All right, last one. Absolute value function. We ready? Absolute value, what does absolute value do? It's the distance. It makes everything positive. So the absolute value of negative 2 is positive 2. Absolute value of negative 1, 0, 1, 2. So negative 2, 2. Negative 1, 1. 0, 0. 1, 1. 2, 2. What this one makes is actually a V. So absolute value has the bars, which make a V. Okay, so then domain, left and right. Negative infinity, positive infinity. And range is, it includes 0, so 0 to infinity.